Hey guys, welcome back to my YouTube channel Coding Gigs. So in the last video we laid the foundation of C++ programming, right? Remember we have studied about the basic structure, code structure that we use in C++. We have dived deeper in the exact words that we use, what are the exact meaning of the words which we use in C++ language while writing the basic program. What does hashtag include mean, what is iostream, why do we use using namespace std, why our program starts from the main function, right? So we have also seen the different types of data types which we use while declaring a variable. We have also seen the size of the data types like int, float, char. Okay, we have also seen the different types of operators which we have in C++ language. So in today's lecture, I'll start with the practical implementation of the types of operators. Okay, so let's see what we are going to see today. We are going to see the practical implementation of operators. Then we are going to see how data is actually stored in C++ language. Then we are going to see the different types of conditional statements. This is a concept in C++. Then we have also different types of loops that we use. Why do we use loops? What are exactly loops? So we are going to see each one of them one by one. And I'll also add the previous video of basics of C++ language in the icon tab. And you can just rewind, pause it and practice as many as time you want. And just understand the concepts. And yeah, so let's start with the video, today's video. So our aim is to start with the practical implementation of types of operator. Okay, so what are operators? We use different kinds of operators, right? So what are they? Those first one is the arithmetic operator. So I'll just give you a glance. Last video also we have studied about this operators. So first one we have the addition one, which means plus. Okay, so I'll just show you a quick one. So let's say I have two variables, int a comma int b, and I'll take the input from the user itself, a and b. I'll say enter and I'll store it in another variable. The operation which we are going to use is addition, right? So a plus b, simple. And then I'll say cout endl. Okay, so let's see, let's run the code. Okay, so let's say I am taking the first value as 4 and second is 2. I'm getting the answer as 6 because 4 plus 2 is 6, right? The next one is also same. For subtraction, which we use is int, let's say sub a minus b, cout sub. So 4 minus 2 will do, which you're going to get 2. First one is the summation answer, second one is the subtraction answer. Similarly, you can also try out with multiplication. See, whenever we are just naming the variables, make sure that you're giving a meaningful name. So it is not necessary every time you have to write the exact word like multiplication. This is a very big word of a variable. So what we can do, we can just write mul, okay, and then we can perform the operation of multiplication and we can store it in a variable. Okay, we are already storing it and simply just print it. We are using endl to print each and every operations in the next line. We are getting an error. Okay, so we forgot semicolon. 4 2. So first one is addition, then subtraction and then multiplication. Okay, so let's show you the modulars one also. Let us see the modulars. Mod. Okay, so let's say 5 mod 2. Okay, and if I see the value of mod, let's see what do we get. I'll just comment off this. Okay, so now you must be thinking, what am I doing in the screen, right? I'm just adding a backslash and then star. So this is called as a multi-line comment. So why it is necessary? Because whenever we programmers, we write the program, okay, and other programmers, we are collaborating with other programmers as well. So suppose if the other programmers want to know that what exactly we have written, so with the help of this comment, we make them understand ki yeah, in this code, in this part of the line, we have written this. This is the explanation of the below code. Okay, and this code is not compiled or run or executed by the C++ compiler. This is exactly ignored, and it is used in terminologies that we use is called as comments. Okay, so let's see what do we get the answer of mod. We are getting the answer of mod as 1, which means that if you divide 2 by 5, you get a remainder as 1. So that is provided by us by the modulus operator. So we generally use these arithmetic operators while doing some logical calculations or while performing some basic C++ program. We'll get to know in the further videos. So yeah, so this was all about the arithmetic operators. You can also try out and explore the different kinds of by using different kinds of inputs. So you can try out with the division one also. Next we have logical operators. So let's see the practical implementation of logical operators. So this was the multi-line comments which I've used over here. If you want to put a single line comment, just simply put backslash 2 times. 2 times backslash is enough. So that was multi-line. This is the single line comment which we use. Next we are going to study about the logical operator. Now what are logical operators? So let's go back to the PPT. Here they have said कि if you use 2 times ampersand, this is called as the ampersand symbol. If you use 2 times ampersand symbol, you are going to use the logical AND operator. So let's see how do we use logical AND operator. So I have written something like if 5 is greater than 2, okay, and 5 is less than 3, okay, simply print yes, else print no. Let's see what do we get the answer. Okay, so we are getting an error, a silly mistake that we have done, which is adding a semicolon. No. Why do we get the answer as no? Okay, so see, 5 is actually greater than 2, but 5 is not less than 3. 5 is also greater than 3, right? So one of our condition is getting false. That's why we are jumping into the else condition. Now this is a conditional statement which we will study in the later on videos. So similarly, whenever we use different logical operators are always used in the conditional statements, or when we are using some kind of different kinds of loops. We have different loops like while loop, for loop, do while loop. So at that time also we use different kinds of operators in order to perform some logical calculations. So this is why we are getting the answer as no, because one of our condition is getting false, because true and false will give you the answer as false. Until and unless both of this condition is getting as true, or if it is satisfying, this code is not going to get executed. If you want to get execute, you simply need to put the right condition. Now you will get the answer as yes. Yeah, because it is greater than 2 and it is also greater than 3. So similarly, we can use this code also, or means that if any of this condition gets executed, you can just print the statement as yes. You're getting the answer as yes because we are using logical or operator. Okay, so yeah, so this was all about logical or. Then we have also relational operators. So let's see the relational operators. So this is a relational operator. See, 5 is greater than 2. 5 is less than 3. So greater than, less than, greater than equal to, less than equal to, equal to equal to. Okay, equal to means you're checking these two values. First value and the second value has been checked with each other, whether it is equal or not. If it is equal, do this. If it is not equal, then do another thing. So that's how we use the different kinds of relational operators. We used arithmetic operators, we use logical operators. So now let's start with the main important thing is how data is stored in C++ language. Okay, so how do we store the data in integers? How do we store data in float, okay, how exactly the data is stored in a programming language, whatever we are using it. See, for integers, there are two kinds of things we know. One is a positive number and a negative number. So the integers are basically stored in terms of binary digits, which is a combination of zeros and ones. Okay, so suppose if it is a positive number, the integer will be converted into a binary number, equivalent binary number, and then you will store it as it is. But in case of negative number, what we do is we calculate the 2's complement of that particular number and then we store it in the memory. Okay, so I'll just give you an example. See, suppose if I have a number, let's say 4. Okay, so how do we exactly interpret it in binary digits or the combinations of zeros and ones? See, whenever you want to calculate any kind of numbers binary digit, what you have to do is use this shortcut. 2 to the power 0, then you have 2 to the power 1, then we have 2 to the power 2, then we have 2 to the power 3. So here I need to represent my 4 in binary digits with 4 bits. These are the spaces for applying the bits. Okay, so this is 2 to the power 4, which means this will be equal to 1, this will be equal to 2, this will be equal to 4. So here you're getting the answer as 4. So you just simply need to write 1 and the rest of the things will be 0. So this is the binary representation of 4. This is how we represent binary 4 in for integers as a positive number. Now let's say, suppose if you have minus 4, how do you represent minus 4 in binary representation, or how do we store it? As I said that we actually calculate the 2's complement, right? So suppose if I have minus 4, so what will be the 2's complement of minus 4? First, represent it in binary digits of 4. So binary digit of 4 will be 2 to the power 0, 2 to the power 1, 2 to the power 2. Okay, so and 2 to the power 2, or if you want another digit you can increase it. So just keep on increasing the power of 2's as you move on. Okay, so here it will be 0, here it will be also 0, here it will be 1, and here it will be 0. Okay, so this is my representation: 0, 1, 0, 0. Excuse me for the bad writing as I am using a laptop. So yeah, so this is my binary representation of 4. Now this particular thing will be converted first. As I said, we need to use 2's complement now. So 2's complement is, first convert this into 1's complement. So what will be the 1's complement of this particular number? Just we need to invert it. If it is 0, just convert it into 1. If it is 1, convert it into 0. Okay, so here it is 0, so 0 will become as 1, 1 will become as 0, 0 will become as again 1, 0 will again become as 1. So this is the 1's complement, and in order to calculate the 2's complement, simply add 1. So this is how we do the addition of binary digits, like 1, 1, which means 0, you again carry 1. Then 1 plus 1 will be again 0, carry 1. Okay, so 1 plus 0 will be 1 and then 1. So this is 1, 1, 0, 0. This is the binary representation of minus 4 after calculating the 2's complement. This is how it is stored. This is the data. How do we store for negative numbers? And for positive numbers, simply we store this part. This is the binary representation of plus 4. This is the binary representation of plus 4, and this is how we can store minus 4 as a data. Okay, and for float and double, what do? We just simply add. Float and double means what? These are the decimal points. Okay, so decimal points are represented by after 2 digits you just simply add a decimal point. So that is how do we represent the float and double. Okay, so suppose if I have an example, let's say 2.5. So 2.5 as an example, and if I want to store it, okay, as a float or data, how do we represent it? Just simply add a f in order to represent that this particular number is a float. That means the computer will be able to understand, okay, this is a float. So you have by simply adding the one single digit letter that you have used is f. So now computer will understand, okay, this is a float. Now I have to simply convert it into binary and store it. So for float and double, this is how do we store. And for character, exactly how do we store is, let's say you have a single character A, single character B, single character B or capital A. Okay, how do we store? We use a ASCII table. So what is ASCII table? I'll show you. So this is a ASCII table. Okay, you can see here. I'll just add this in my notes section. You'll refer it. You can refer it. So ASCII table means that whatever single characters we have over here, this is the representation. This is a chart where it represents each and every characters uniquely. So computer what will do? Suppose the value of my capital A, if you can see here carefully, it is 65. So A is represented using number 65. 65 will be again converted into a binary digit, and then that particular binary digit will be stored as a part of a memory in a storage. We'll store it, and that's how we exactly store the characters. Okay, so I'll give you a quick revision. For integers, if you have a positive number, the exact binary representation will be stored. For negative, you need to calculate the 2's complement by taking 1's complement, add it plus 1, and then for negative numbers here it is stored like this. And then for float and for double, we simply use this small f to represent, and then accordingly the computer will convert it into binary digit. And for characters, what do? We refer this ASCII chart, okay, ASCII table, and then the corresponding value or the number of a particular letter that we will use, we'll consider it, we'll convert it into binary digit, and then we will store it. So I hope you have understood this part. Okay, so now let's move on to the next very important thing in C++ language, which is conditional statements. Now what is conditional statements? Conditional statements, we have these three things. We have already seen in the flow charts. Like we have solved a problem which was in order to check whether the number is even or odd, right? If you remember. So there we need to first satisfy a particular condition. So if that condition is satisfied, then we can say the number is even. If it is not satisfied, then we can say that the number is odd, right? So we have three types of thing. One is if, one is if else, one is if else if. So we will see one by one. What does it mean? See, this is the flowchart of a conditional statement. Suppose you have been given an expression, you need to evaluate this expression. If the evaluation of a particular expression is true, then we can execute this block. If it is false, we can execute this block. So this is how do we represent the conditional statements in particular flowchart using this diamond shape. If you remember, these are the components. Okay, so we have three types of conditional statements. One is if, the other is if else, the other is if else if. We'll see one by one in the GDP compiler. Now how do we represent if statement? What is the syntax? The syntax of if statement is if, put some condition, let's say 5 is greater than 2. Okay, then see out, yes, 5 is greater than 2. Okay, if I print this part, you are getting the answer. So this is how we represent the if statement. If means if this particular condition is satisfied, then only this block of code will be executed. Otherwise, you are not going to get any answer. Okay, and what is if else? If else syntax looks like this: see out, exit. Okay, suppose if the condition, if I put this 5 is less than 2. Okay, So this part will be executed, which is exit, which means that condition that we have specified in if is not satisfied. That's why we are executing this. Matlab, if you are doing this part, then only execute, otherwise execute this block of part. So that is how we represent it in if else statement. Okay, next we have if else if. Okay, if you see my presentation here, we have if, we have covered this part, we have also done this. The next one is if else if. Now what is if else if? It means that you can add the number of conditions, like if this part is not executed, check for this condition. If this part is also not executed, check for another condition. And if this is also not executed, or this is not the condition specified in this part also is not satisfied, then at last just perform this block of code. So that is how we use it. Okay, the else if part. So like if it is less than 2, okay, and you check if 5 is greater than 3, okay, if this condition is executed, let's say yes, 5 is greater than 3. So which means that if this particular condition is not executed, try for this, check this condition. If it is executed, then run this piece of code. If not, then go for this. Okay, so let's see what do we get the answer. Yes, 5 is greater than 3, which means that this evaluation got the answer as false. This evaluation got the answer as true, and that's why we did not move to the next block. Simply we have executed this part, and I have executed and I have terminated my code. So that's how we execute the if statement. We have executed the else if else if, and then if and else block also. We'll see the number of questions. As many as questions we solve, you will able to understand, you will able to grasp the concept. So we have also a particular separate videos where we'll be solving different kinds of questions, basic questions related to by using the types of operators, okay, by using conditional statements. So for that, what will happen is, if you practice as many as questions, basics questions, you'll able to grasp the concept and you'll become a pro kind of programmer in C++. Okay, so let's move on to the next one. So we are going to start with the loop part. Now what is loop? Loop means happening again and again, again and again, again and again. Whenever you execute some task and you want that task to be executed again and again, again and again, again, until you have any kind of stopping criteria. Okay, so that is called as loop. Now in real world example, if I give, it could be your fan. Like when you switch on the fan, it keeps on rotating, right? Like this, it keeps on rotating until and unless you switch off the fan. So that is called as loop. So your fan is rotating on a loop. Okay, so similarly in programming language, we also have loops to execute some particular task until and unless you specify a stopping criteria. Okay, so the different kinds of loops which we have is, first we have while loop, okay, then we have do while loop, okay, then we have for loop. So we are going to explore all of this. Okay, so what is the syntax of while loop? While, which is a keyword in C++, then you have a condition, you need to execute some code 1, code 2, and then you need to update the expression. It could be a incrementing or decrementing. So this is how you execute a while loop. Now why it is necessary? Each of this part is very necessary. Before using this condition, you need to initialize a variable. Okay, then you need to, first point is you need to initialize the variable. Second point is you need to specify the condition. Third point is you need to specify the code that you want to execute if the condition is satisfied. If it is not satisfied, your while loop will not work. Third is to update the expression, which is either you increment that variable which you have initialized or either you decrement it. Now why this update expression is required? Because if you don't specify this update expression, your loop will keep on executing infinitely. Your loop will not terminate. It will keep on executing, your system will get crash. If I give you an example now, let's say I'll provide you all the piece of code in the note section so you don't have to worry. So let's say I have a value, let's say int I is equals to 0. While my I is less than equal to 10, cout I ended, then I plus plus, you are incrementing it, which means that you are updating the statement. Okay, so if I run this program, you're going to get the number right from 0 to 10. It is executed, right? 0, 1, 2, 3, 4. If I zoom in the video, the screen, if you can see here, 0 to 10, the numbers are executed, right? So how did it happen? We'll see one by one. So till now we have seen what is while loop. We have introduced the concept which is called as while loop, right? So till now we have not seen the exact functionality. How does my code work? We are going to see it in the next upcoming video. So let's quickly just check out that what exactly we have learned till now. So we have seen the types of operator. We have seen the practical implementation of arithmetic operator, the practical implementation of logical operator, relational operator. Okay, then how exactly we store data in integers, in floats, in double and in character, right? We have also seen the conditional statements, if else, if, right? We have also checked the practical implementation also. I have shown you with the help of code also, and I have introduced you to the while loop. Okay, so we will just see the exact implementation, how the functionality works on step-by-step process of while loop, along with the syntax and some few problems in the next upcoming video. So please subscribe to my channel, and I hope that you like this video, and keep your bell notification on so that you will get the notification of all the videos whatever I am uploading on time. Thank you. Keep learning.